Hello. Hello. Are you there? Can you just connect your audio there? Oh, great. Can you hear me? Aline. Aline. Hello. Can you check your chat messages there? I cannot hear you. Oh my God. Mute by control. I don't think it's my side. Why can't I hear you? Can you just type there if you can hear me? Just indicate there on the messages. Hello?
Hi, can you hear me?
Yeah, I can.
Okay, so I was using my laptop and I think something's wrong with my mic.
Okay, but there's so much noise. I don't know what's going on there.
Yeah, okay. Let me leave it. Okay, now what's going on?
Yeah,
Sorry about that, because I was so lost and my brother's in the other room, so I'm not gonna ask him for help because
yeah,
I'm
it seems
stubborn.
okay.
But anyway, sorry about that.
Yeah, it seems okay. Let me just
Okay.
let's just start it. Get
Okay,
on
no
with it.
problem.
Can you see the board, right?
Yeah, I can.
Okay, that's good. So today we'll be doing planes. Actually, we've been busy with lines. So
Okay. Yes.
so today we'll be doing planes. Just to remind you. Oh damn, what's
Okay.
going on here?
All right. Because I did have a few questions, but it can wait until the end. It's fine.
Oh, you did have three questions. Okay,
Yeah, because
okay. Continue asking.
okay. Okay, so yesterday, for the one of, when you consider the points, then they give you a point and a line, and they say find the distance from point P to the line L, right?
They give you a line and a point.
Yes, yes, yes.
And then they give you okay, there's a point here and then a point
It's a
somewhere.
line.
Yeah, it's a line here.
Yes.
The point is on the line or it's somewhere else. Okay, there's
They
a
just
there's
say,
a there's an origin here. There's normally a point somewhere, and then they say find the distance between the point and the line.
yeah, here they just say consider the point P, and then they say minus one, 1, and 2, and then the line L, which is x equals to 1 plus t, y equals to 1 minus t, and z equals to 2t. So then they say
Okay.
find the distance from point P to the line L.
Okay,
So
yeah.
I got a negative distance, and I don't think that I'm supposed to get a negative distance.
Nah, there's
So
no,
that's
there's
where,
no, there's no, which, did you use the formula that I gave you or?
yeah, yes, I used the problems that you gave me, and I don't think there's supposed to be a
Oh,
negative distance.
there's an absolute thing going on there. Let me show you the formula.
Really?
There, there there's
Okay.
there's an absolute. Let me just check if you're using this formula. Maybe I didn't put the absolute there. Let me just share this with you really
Okay.
quick. Um, where are we now? Okay. Yeah, there it is. You're talking about this formula.
Yeah, I use that formula somewhere, somehow. I use that
Yeah,
formula.
there's supposed to be an absolute thing here. It changes everything to positive.
Oh,
Yeah, so
okay.
yeah, maybe
Okay, okay.
I
It's
probably
fine.
forgot to put the absolute thing.
I think it did, but I was probably thinking that it was a mistake and why is it there? Because I'm not used to be like the distance formula being like that. So I think I should also double check with
Yeah,
that. Because I
yeah,
think I put a square root and here it's like, yeah, okay, I see now. It's fine.
yeah. Okay, that's good. But you can you find can you find let's go back here. Are you able to find the distance when you're not given the equation in Cartesian form?
I don't think I've come across something like that.
When it's
As
in
in on
uh,
given points.
yeah, when it's in parametric form.
Yes,
That
I can.
oh you can, that's good then. That's
Yeah, because
good.
I think the last question was about that and I was able to get the distance.
Oh, that's good. Yeah, yeah, yeah.
Okay.
Yeah, let's just move on. But I just want
Let's move on. Okay.
okay. Normally you are given a line L, like I have drawn here, and then
Okay.
you're given a point A, and then you always draw you always put the origin here when you're
All
dealing
right.
with such questions. You just imagine the whole thing is on a XY plane, but you don't have to draw that thing, the XY plane. You just draw a random point, and then you must always put the origin.
All right.
So for a line, we had two equations. Now we had the equation. The first one was the parametric one. It was x0, and then we've got the parameter, and then we had the parallel vector. In this case, it was something like this. Yeah, a vector that is parallel to a line, like this, right? That's one form.
Yes.
That's one form of the equation of a line. And then the next one, it's this one, you know, from high school. It can be written in different formats. It's mx plus c, or we can write it as is it a x plus b y plus c equal to 0. Yeah, or you can write it like this, whereby
Okay.
yeah, it's the same equation as this one, but this one,
Yeah.
yeah, and then the a and the b, you can, these points a and b, you can make them a vector, right? You can make them a vector,
Yes.
and that vector will be perpendicular. For example, we have a line here. That vector will be perpendicular. Let's say this is a and b. This vector would be perpendicular to the vector of the line, perpendicular to the line, basically.
Okay.
I can make an example quickly. Let's say you have, let's just throw a line like this. You have, let's say you have, yeah, let's just say you have 4 here, then we've got 2 here, right? It's a line, right? And then the equation would be y is equal to minus 2 is the gradient, and then 4 is the y-intercept. So we have an equation like this. It's in this format. It's in this format.
Okay.
We can turn it into this format by saying 2x plus y minus 4 is equal to 0, right? And then these two
Okay.
numbers, 2, comma 1, if we create a vector 2, 1, it will be perpendicular to this line, right?
Okay.
You can create a vector using these 2 points. You have 40, you have 4. Oh, sorry, you've got 0, 4, and then you've got 2, 0, and then the vector between these 2 points will be equal to -2, 4, right? And then it's probably gonna be smaller. The vector maybe it's gonna be somewhere here. This vector will be perpendicular because the vector is also parallel to the line, so you can either say the vector or the line will be perpendicular to this vector. You can prove that. You can prove that by perpendicular vectors they dot to 0, right? You can dot these 2 things, 2, 1. You will get -4 plus 4 is equal to 0. But the reason why I'm showing you this, it's just a summary. Basically, the summary is that for equation of a line, we've got these 2 equations here.
All right.
Yep. So you should understand what the A and the B stands for. You already know what
I think I got that.
Yeah, okay, let's move on to oh shit. How do you this thing can be complicated?
It is really complicated.
So now we're moving on to a plane, right? A plane is something.
All right.
A plane is something like this. Try and make it 3D. Yep, something like this. And then you always throw the 0 here. So we've got a plane. Eh? When you're describing a plane, you will normally be given a point, just like a line, given a point, right? A plane must also be given a point, and that point you can turn it into a vector coming from underneath. Just imagine this line coming from underneath, and then you're gonna be given 2 other vectors, or you're gonna create them yourself. You can create this vector, and then another vector, something like this. These 2 vectors, they must not be parallel.
Oh, okay.
So basically, you can describe any point here. Call this point, whatever. We call it R. You can describe a point anywhere on the plane using the equations, almost similar to the one for a line. Just that now you've got 2 vectors. These 2 vectors, remember on a line we had a vector that was parallel to a line.
Yeah.
Here we've got 2 vectors that are parallel to the plane, right?
Oh yeah, not to each other, just to the plane.
Yeah, to the plane. So any 2 vectors, because a plane has many different lines. Some lines are going like this, some lines are going like this, some they can slant different ways. So there's just many ways of drawing a line on a plane. But we use only 2 vectors to describe in parametric form. So this is gonna be T, then V1, then plus maybe another parameter, then V2. And this V1 will be this one, or V2 will be this one. And then we also have another, like the line, remember we had a parametric equation, and then we had a Cartesian equation. So the same thing with the plane. We have a parametric equation, and then we have a Cartesian equation, and it's like this: b y minus y1 plus, it's plus what? This is c, right? It depends if you're in 3D or 2D. We're just gonna use the 3D one. Plus z minus z1 equals 0. So you've got 2 equations. Once you understand these equations, you are done. Then A, B, C. We can create a vector just like in a line. In a line we had A and B, so here we can create a vector A, B, and C. And this vector is perpendicular to the plane. This one, it's perpendicular to the plane. And then X, Y, Z1 is just a point on the plane. And you are done. That's all you need to describe. And then after that, you just answer questions. Maybe we can just do one example.
Okay.
Can just do one example. I'm just checking the book because
No problem.
the thing is I can't share my phone, and most of these things are on my phone. So let's.
Oh yeah.
Let me just jot it down. Let me just jot it down. It's a page. Suppose we have a point, right? The point is 3, 4, -2. Let me just maximize this thing. That's the point. Hopefully you can see it. And then we've got two vectors. The vectors, they are parallel to the plane. So we've got 5, -3, 1, and we've got 4, -1, -3. And then they say find the vector parametric equation of the plane. So you would just put the point that's on the line. Remember a point, that's on the plane. Remember a point, you can turn it into a vector. So it's interchangeable. You can call it a point or a vector. And then you put a T here. Then you put one of those vectors, -3, 1, then another parameter, 4, -1, -3, and you're done.
That's it.
That's it. And then the one for, let me look for the one in Cartesian format. Yeah, they might say, oh, okay, the one in Cartesian format, they will have to give you a vector. They'll have to mention that the vector is perpendicular to the plane.
Oh, okay.
Let me just check this. I'm looking for an example in the book, but oh yeah, there it is. Okay, let me just write this down. Another example you might be given, it's just long sentences. I'm just gonna summarize. They tell you that the equation, they're asking you to find the equation of a plane in Cartesian format. They're saying that there's a point on the plane 2, 1, -3, and then there's a vector that is perpendicular to the plane, and that vector is 5, -2, 1. So you're given these two information, these two vectors. So in Cartesian plane, you just go straight, you jot down there. Can you hear me? Hello?
Oh, was it me?
I don't know what happened here, but just,
Hello?
yeah, I can hear you.
Oh, okay. I thought maybe something happened with my network. So,
Something happened.
okay.
I don't know what happened, but something happened.
Yeah. It's fine though.
Okay, there's a point, 2, 1, -3. This point is on the plane. And then there's a vector. The vector is 5, -2, 1. And then this vector is perpendicular to the plane. And then they say find the equation of the plane in Cartesian format. So you just, because it's in 3 dimension, so it needs to include that is equal to 0. Then remember, A, B, C represents this only if this vector is perpendicular. If it's just some vector that is not perpendicular, then you cannot use it. Are you there? Hello? Hello?